So today we will be talking about reducing inventory at the West Switchboard complex over at Siemens. My name is Yanina,
And I'm Mark.
and this project aims to reduce rack inventory by 15% and improve Kanban location accuracy by 100% using the DMAIC methodology.
To provide more background, Siemens is a global leader in industrial manufacturing, automation, and digitalization. Our plant specifically focuses on low voltage and high voltage switchboard production. And as for our goals, our objective is to identify inefficiencies in their Kanban system and propose improvements. And our scope will be focusing on the distribution racks and mechanical assembly racks within their West Switchboard facility. For our define phase, we conducted stakeholder analysis to identify their specific interests, expectations, and potential concerns. Additionally, we created a SIPOC diagram to define and understand their switchboard assembly process.
Next, for measure, we identified their current state and found that the racks have no visual control for inventory. There's many missing labels, or a lot of parts are obsolete, and overproduction was caused by duplicate part orders. Next, for the data collection, we found the consumption rates for each part over the last 6 months. We found the weight of the parts and the bin size on each rack, and the inventory required for the mechanical and distribution assembly. As seen on table 1, we can see the rack percent error for each rack, and then as seen on figure 2 and 3, we can see the consumption rates for the racks. Next, for analyze.
We conducted a root cause analysis by interviewing many of the engineers and operators working within the West Switchboard facility, and we used methodologies such as the 5 whys and fishbone diagram to understand the root cause of high percentage of Kanban inaccuracies as well as excess inventory. Figure 4 shows the steps that we identified that was causing that high percentage of inaccuracies.
For the improved part of the methodology, we conducted a pairwise comparison using 4 factors to create the new rack layouts. And we did this to rank each factor based on stakeholder feedback.
Afterwards, we developed a process flow map outlining the steps for Kanban inventory replenishment, which is based on the current process in East Power Panel production.
Lastly, in our methodology, we did control, which was focused on standardization, where we made sure all of the bins were standardized to create a uniform look and fit each rack exact. Next, for the new Kanban replenishment procedure, it will be handed out to the West Complex foreman and fixed based on feedback after a 2-week pilot. And to implement Poka-Yoke, the new inventory rack labels will have individual engineering drawings of each part to visually confirm the right part was picked, as seen in figure 8.
As for our results, the 6 figures above show the redesign of the Kanban inventory for the racks within distribution and mechanical assembly. In the end, we were able to achieve an inventory reduction of 20% as well as 100% Kanban accuracy. While the new layouts are pending a full implementation, our analysis confirms that all the parts required for their daily production have now been clearly designated a location on both the physical racks as well as the SAP system. This will eliminate overstock and prevent random placement of excess inventory, significantly improving inventory control and process visibility.
Lastly, we just wanted to thank the IE department, our professor, Dr. Rogers, and the Siemens team, especially Ginevra, for helping us complete this project. Thank you.